Okay, let's move ahead into the realm that we're used to in an algebra class. Most of the time, our functions, really, throughout the course, are not going to have names and dates for their inputs and outputs. They're going to have numeric inputs and outputs. So if the inputs and outputs are numbers, then we tend to represent the inputs with X and the outputs with Y. That's going to be familiar to you. And in that case, a relation may be described with a set of ordered pairs. So in a primitive sort of way, a relation might just be the three ordered pairs 0, 1, 1, 4, 4, 4. And you should understand that the X coordinates are the inputs and the Y coordinates are the outputs. So let's look at this first relation, three ordered pairs, and ask whether that is a function. Well, let's see. Each input has to have exactly one output. Input 0, the output is 1. If you know the input is 0, then you know the output is 1. 1, the input 1 goes to 4 as an output. The input 4 goes to 4. We've got a lot of 4's going on here, and we've got a couple of 1's as well. But I don't have any question about where an input goes. The inputs are 0, 1, and 4. And if I know which member of the input set of the domain I'm looking at, 0, 1, or 4, then this list will tell me exactly what the output is. The only output for 0 is 1, the only output for 1 is 4, the only output for 4 is 4. This is a function. And moreover, the domain of this function is the set of inputs 0, 1, and 4. And the range of this function is the set of outputs 1, 4. It's okay that the range has fewer elements than the domain as long as the mapping tells us exactly one output for each input. The situation here is actually similar to the book club example where we have two different outputs, two different inputs, 1 and 4, that go to the same output, but that's okay. I still have a function going on here. Here's another relation defined by a set of three ordered pairs. 0 as an input has 0 as an output, that's fine. 2 as an input has 15 as an output, and 2 as an input has 1 as an output. So here is the chuck in this example. Two different inputs, or I'm sorry, the same input, 2, in two different ordered pairs, is trying to have it two different ways. It's got two distinct outputs. So I haven't got this situation where an input has one and only one distinct output. Failure. Not a function. And I guess we can see that most distinctly here because two distinct ordered pairs have the same x coordinate. So that'll be the elephant in the living room. If you see two ordered pairs with the same first coordinate, you're probably not looking at a function. In addition to describing functions as sets of ordered pairs, actually most of the time in this class, we're going to look at them using formulas and equations. So a function or a relation can be described with an equation as well. And these two equations describe two different perfectly good relations. I guess in this case, the output y would be found by squaring the input x. And you can think about whether this thing would be a function. It's a little bit trickier with an equation, but basically the question is, if I take a value of x, input into this equation, I'll square it, I'll get a particular one unique number, which is the square of the input x, and that will define y in a very explicit way, so that for any given real number that I square, there's only one value that results from that operation. So this is definitely a function. the domain and range excuse me, are a little bit trickier to find than they are to just pull off x's and y's from ordered pairs, because they're defined kind of implicitly from all the real numbers that could work here. So unless there's explicit directions about what the domain is, you look at the equation and say, what values of x, what real numbers could be squared here? And the answer is I can square any real number, so the domain is all real numbers. We'll sometimes just use a capital or script R to describe that set. And what's the range? The range is any of the outputs, any y's I could get here. A little bit of thought will tell you that the range is not all real numbers, because when you square a positive number you get a positive square, and when you square a negative number you get a positive square, a positive output. I guess if I input 0 I can get an output of 0, so the range here expressed in interval notation would be all the real numbers from 0 to infinity, including 0. Following rules of interval notation here, I'm going to use a square bracket with 0 because that is one of the outputs I can get, and I'm always going to use the round half parent with positive or negative infinity. So this is just a way of describing the non-negative real numbers. Now how about this guy? Well, you might spot the pattern by now. It turns out this is not a function, but y. Well, for a particular value of an input, like say x equals 4, there could be more than one output, because y could be positive 2 or negative 2, and the square of y would give you positive 4. Generally, the easiest way to see that this is going on is to try to solve for x explicitly. Solve for y rather. Solve for y. And let's see, y squared is x, y is one of the square roots of x, plus or minus. So my output is plus or minus the square root of the input, plus or minus the principal square root. So that means that for a positive value of x, I'm going to have not exactly one distinct output, but 2 outputs, and that's not allowed to be a function. So this guy's perfectly good relation, but it does not define a function. See you later.